Welcome to our channel. Today we will delve into an exciting problem involving strategic investment decision that a company must make before its IPO, initial public offering. Our task is to help LeetCode, a renowned tech company, maximize its capital by selecting the most profitable project to undertake before going public. Let's understand the problem statement. LeetCode has a list of projects, each characterized by two attributes: profit, the net gain the company would earn after completing the project; capital, the minimum investment required to start the project. Given the company current capital, LeetCode wants to maximize its total capital by selecting up to k distinct projects. However, there are constraints. The company can only select projects it can afford based on its current capital. After completing a project, the profit from that project is added to the total capital, potentially allowing the company to undertake more projects. To summarize, our objective is to maximize LeetCode capital by wisely selecting and executing projects within the given constraint. To tackle this problem, we need to employ a strategic approach that ensures we select the most profitable project that can be initiated with the available capital. The step-by-step breakdown of the solution is: first, we sort the project based on their capital requirement. This helps us efficiently find projects that can be initiated with the current capital. Then we use a max heap to keep track of the most profitable project that can be started with the current capital. This allows us to always select the project with the highest profit. For each project selection, we use iterative selection. We add all projects that can be started with the current capital to the max heap. If the heap is empty, it means there are no more projects we can afford, so we break out of the loop. Otherwise, we select the most profitable project from the heap, add its profit to our capital, and continue to the next project. We repeat the selection process for up to k projects or until there are no more affordable projects left. Let's write the code. And of length profit. For that, first we create a list of tuple of capital and capital of list of tuple of capital and profit. For that, project equal to in list capital of I, profit of I. For I in range of n. For that, we sort the project by the required capital. For that we write project sort dot sort. Then we make the heap to store the most profitable project we can currently afford. For that max heap, we create list of max heap I equal to 0 for in range of k value. Here we add all the projects that can be started with current capital to the max heap. For that, we write while loop where I less than n and project of I 0 less than equal to w. Heap q dot heap push where max heap minus project of I and 1 I plus equal to 1 for increment. If no more project can be started, we break the statement, break the loop. For that, if not max heap, we break the loop. So we start, we check the most profitable project we can afford. For that, w minus w equal to heap q dot heap of max of heap return w. So here we first create a list of tuples where each tuple contains the capital requirement and profit of a project. This list is then sorted by capital. We initialize an empty heap to store the profit of project we can afford to start with our current capital. Within a loop that runs up to k times, we add all affordable projects to the max heap. If the max heap is empty, we exit the loop as no further project can be started. We then extract the most profitable project from the heap, add its profit to our capital, and process. After the loop, the final value of W is our maximized capital after selecting up to K project. This approach ensures that we always make the best possible decision at each step, leading to the maximization of LeetCode capital before its IPO. Let's run the code to check. Okay, there is one error, syntax error. Okay, let's run again. Okay, it accepted. Let's submit the problem solution. Okay, it accepted. That's all for today's video. If you found this explanation helpful, don't forget to like, share, and subscribe to our channel for more insightful content. Thank you for watching and happy coding.